All right. So afternoon, everyone. Thanks for having me here, and also thanks to the BRCA team for the opportunity to have me present my research that I have been doing for the last 8 months. I'm excited to share this research with you, and as the title says, I'm here to explore if the ISPs and the residential gateway they gave out to you are safe. Let me do a little bit of introduction of myself first. I'm Tadun Yan. I'm a vulnerability researcher working at TX1 Networks, a company focused on industrial network security. And my work is to basically break everything. I have several expertise in numerous fields. I have multiple presentations around firmware, and I feel it's worth to mention that it's my honor to present here at the stage of the BRCA Europe for the first time. So let's get started. As the title says, we're talking about residential gateway today. And what is a residential gateway? A residential gateway is something that bridges your premise to the internet. And there are multiple kinds of devices that can be called residential gateway. But today, we're only discussing what is provided to you from the service provider when you sign up for fixed internet service. And why is this topic important, and why are we talking about it today? So, according to a survey, 79% of households in the world has access to some sort of fixed internet, which means 79% of households may have a residential gateway. And from numerous news reports that I know they could be lucrative targets for adversaries, I have not seen a report against residential gateways, especially the ones that are provided to you by the service providers. So, I think the audiences here will tend to ask a question, that is, how many residential gateways are there on Earth? The answer could be at least 153 million. And why and how do I know that? Well, first, I have a beautiful world map for you here to show you the approximate concentration of residential gateways in the world. And I will show you the reason why would I know that later in the slides. But let's see about the past cases about people being able to find bugs in either service providers' remote management expert or on the residential gateway themselves. There are actually research done by Shahar Tel, Peter Gassier, and Sam Curry in the coming years. They either find bugs in the remote management expert or on the residential gateway themselves and allowing one to take control of many devices. And the reason I'm doing this research is roughly a year ago, I took a look inside a service provider and their gateway and their remote management expert. It turns out to be not very good and becomes a very sad story, which ends up with me being able to control over 4 million devices. So I have expanded that research into 14 devices across 11 ISPs. In 9 countries. As a brief conclusion, I found out that most residential gateways are not very safe, neither the service provider behind them, and I will elaborate why today. I have picked up some cases here today to present them to the audiences here. They are most likely interesting to the audiences, and the other cases will be addressed via the white paper and write-ups we'll be releasing later. So we'll be demonstrating some cases. One is to get started to how to study a residential gateway. And from that case, we can expand to how to study the remote management aspect provided by the provider. And we can share a case where an OES implementation of TrustZone is able to be bypassed. And another one is how to find bugs in a very popular vendor's SDK. And why does residential gateway warrants such research? So let's take a look about how modern infrastructure is laid out. For example, in the electricity generation sector, every aspect of that sector actually needs some kind of telecommunication to work. And I can already see there were past cases of adversaries trying to take out other aspects inside critical infrastructure sector via attacking the telecommunication sector. So let's get started. Let's see how should one begin in studying how the residential gateway and every protocol in between the provider and the gateway themselves and on the ISP side. So these are numerous protocol standards and some of the brands, either the OEMs or the soft vendors, that you could refer to, and you could start from there. But I have a better one. I have created a wonderful graph telling you about what happens between the provider and you. On your premises, there should be a residential gateway if you have some sort of internet access, and will be indicated by the rectangle RG, which stands for residential gateway here on the right-hand side. And there are numerous devices between the internet and you. And what are these devices? On the most left-hand side, there is an internet exchange inside the provider. It's most likely comprised of many network switches. And there are a device called brass, which is responsible for managing the subscribers, and OLT, which focus on converting anything to GPON and using that GPON protocol to connect to you. But we are only focusing on two aspects inside this chart today, which is the residential gateway and the remote management aspect from the provider. And why is that? So obviously, the residential gateway is the only thing that exposes your premise to the internet side, because you obviously need that thing to connect to the network. For the remote management aspect, this is a bit complicated, because the remote management aspect, you could imagine it like a server that is able to somehow push configuration files to a residential gateway through the internet. So should you be able to somehow compromise the remote management aspect for a provider, you will be able to take control of the residential gateways under that provider. And a way for me to perform this research across many devices is I tend to focus on the residential gateway themselves. I know the gateway themselves are already well connected with many attack surfaces available. And I will start from the hardware of such devices, and I have bring some of the devices that I have started here. From those hardwares, try to figure out how that hardware works and try to extract the firmware on it and try to figure out what does the software and network stack looks like. And moving on from there, try to figure out how the management aspect of that provider works. So, as a conclusion, I have done this method across that many devices, and it appears that on most residential gateways, I have a feeling that most gateways are built, even in 2024, it is built like if we are in 2004, sorry. So, a lack of modern practices are very common, and something I call sort of UI to root is also very common. And you don't need any fancy pounding box to take control of a residential gateway. All you need is common injections. How about the provider side? The provider side are not very good either, because for many providers, they tend to expose their management aspect on the internet, and it's possible for you to find a bug in that management aspect. And for here in Europe, I do see there are calls to remove Huawei and ZTE in 5G network, but there's still use of these two vendors inside a fixed network infrastructure. Right. So how do you start studying such residential gateways? As before, I have created a wonderful flow for you to decide how to interact with a board. And in most cases, I don't think you actually need this graph, because in many cases, you can just use Google Foo. That is a very useful tool. Or try to throw Burp Suite with active scan mode against the local site management aspect. And you may find some ways to elevate your privileges and gain command execution ability on the board and working from there. But let's pretend that this tool didn't work. So you will resort to this. You will try to tear the thing apart and try to figure out how to interact with the thing. But you can apply that flowchart I have shown you earlier and try to identify every component on the board and try to think of any input or output opportunity on the board. And for this one, this is actually a case we will be presenting later. On this one, you will find there's a 0-port expert on the board, and you could try some tools to figure out what kind of stuff is on that port. And for this board in particular, it actually runs a 0-port protocol. And for most boards, it works roughly like this. So when you power it on, you'll try to load the bootloader and load the operating system. And you will also have some kind of fallback mode should it fail. And in that bootloader mode, in some cases that the boot selection may not be disabled, and you can work from there. But if it is locked, you can somehow try to interrupt the loading process. The actual details were a bit scary, which may involve using a paperclip to poke at a flash chip's data pins. But that is one of the methods, but kind of risky. In other cases, you can try other more peaceful methods. I want to mention that for targets like residential gateways, desoldering may not be the best because in most cases, you may not actually own the device, and breaking the device may cause you some problems. But you have many ways to interact with the board. So for example, using a clip or probes or to solder wires onto the board, which I will go into depth on the next slide. Or in many cases, like I said before, you can use either Google foo or GitHub foo to find the corresponding information. So for the images in the middle, this is a bit interesting because some boards actually needs what I call the man-in-the-middle method, which is actually this board I'm holding on in the hand. So it sometimes requires you to actually scrape the traces out from the board and try to figure out how to connect to the flash chip and perform your next step from there. But I have also found out a gimmick. So what if you accidentally erase all the markings on the chip? A wise man once said, engravings gives you no technical advantage whatsoever. So I have improvised a way. You can recover these markings with a pencil. So when you have done these steps, you may end up with a firmware image, and you can try several methods to figure out how this works. But in many cases, you may not know how to work with this image, so you can try something like figuring out what repetition it has in that image. So for example, for this one, if you look more closely, you will see a certain string, and put that string into GitHub foo, you will find a tool that is very useful that enables you to extract RS version 2 firmware packaging format. So let's move on to the actual studies. We will be presenting two actual cases, two boards today, and this is one of the cases. The case one is actually based off a Broadcom Generation 3 board. So, which means it will be having secure boot and root of trust capabilities, and it will have full disk encryption. So even if I were to desolder the chip from the board, I will not be able to read it, and I shall not be able to extract any cryptography information. And for that provider, in particular, it actually uses a certificate to authenticate with the network. So if I were to take another GPON device to connect to the fixed network of that provider, it will not work because I do not have that certificate. And for this board in particular, the problem with this it is a very well-made board. It has tons of components on it, and is kind of difficult to obtain this one. So I do not want to break it. So, as a people like me, not very good with micro desoldering/soldering, I tend to procrastinate a bit. So I put that device back to the shelf for maybe 1 or 2 months. After 1 or 2 months, I decided to take another look. So I decided to put it into Google foo. I somehow find discussion of this board in China. So, in China, there's a network forum called Ancient Wi-Fi Hobbyists, and contains mentioning of this board. And it appears that the Chinese were buying this residential gateway for Wi-Fi stations. Nevertheless, I managed to find the firmware distribution page in this forum. When I got to that page, it was taken offline by the vendor. But I'm able to recover the contents thanks to the project by the Internet Archive, So I'm able to obtain another model's firmware by the same vendor. And the best part, that one is encrypted. So I now have a file system image of the different model, but from the same vendor. But because that is from a different model, I will automatically need a way to dump firmware and perform code execution on the device I have on hand. I took some look into a LAN management aspect. It appears to be a bit safe. There's nothing much on the WAN side, and I certainly do not want to break the board, which means I do not want to desolder stuff from the board. So I look at the unencrypted dump from another device. I took a bit look. It appears to be containing some interesting UDEP rules because the board actually has systemd UDEP compiled in. And I took a look again at that rule. It looks like if I connect a FTDI UART dongle to the board, I will make the board somehow execute some binaries. So, as a people like me, I tend to have tons of dongles in my cardboard. So I took out one dongle, connected to the board, and I was greeted with a greeting on the 0 port. So when I connect to it, it will greet me with protocol 1.0. And I don't know what to do, so I put a tons of A's inside because I don't know what protocol it is. And I was immediately evicted from the protocol. So I threw that binary into disassembler, and it appears that it implemented some kind of proprietary protocol, and it is an opcode-based protocol. And the reason I got evicted is because it actually requires a fixed password. So I wrote a dissector for it, and I shall be able to communicate using the protocol. So now I'm armed with that dissector, and I took out the dongle again, connect to the board, and I put in the correct password. I am greeted with protocol started. And since I'm not, I haven't done the full, I didn't do the full reverse engineering at that point. So the thing I did in the first place is I randomly tried to put some stuff after an legit command. And I automatically get command execution on the board as root, which was very good. So in this case, I somehow have a thing called physical code execution on the device. The physical part is because I have to actually physically interact with the board. So physical code execution as root on the device. The problem with the case 1 is it has the keys in escrow of root of trust, and yes, decrypted by TrustZone, but it is not secured when it becomes data in use. So I'm able to extract all of the cryptography materials, despite the board should be using TrustZone. And it appears to be an oversight on the OEM side. Let's move on to case 2. So the case 2 is an actual case. So I took the same method and looked into case 2. And it appears the case 2 demonstrates the most common problems with software on residential gateways. Despite a common lack of hardening, you don't actually need to rely on that because you can find tons of common injections on the board. It is on the level that you can use kite fuzzy and find tons of common injections. However, the bugs were mostly LAN side and it's not WAN side. So if we want to study whether if this provider and their residential gateway are safe, we will automatically need a way to expand our attack primitive. So I look more closely into that device. It appears that the device implements some interesting IP table rules. So certain IP ranges can reach the management aspect on that device via the WAN side. And another interesting stuff here is it appears to only block the ICMP request, but not other types. We will go back on this later. So we now have post-authentication RCE on the management interface, but we still need to escalate this bug to pre-authentication. So I figured out a way to enumerate the admin password on every device because it is used. The password is based on some certain rules, and there's a guest account on every device that enables me to enumerate that password. So I have a way to enumerate the password and turn the post-authentication into pre-authentication. But we still need a way to reach the management interface's WAN side from the internet, which we're still missing right now. So I took some look at that IP ranges. And here are some prime examples of how to find management infrastructure on the internet. So the ones shown here are actually the ones you can find right now on the internet. And they are really the management expert of some certain service provider right now. You can try to find them. So where are we right now? Let's see. Those interfaces are actually marked in which I have marked as orange in this chart. So we are now here. So for that provider, I have looked into that allowed list, and it appears it contains some interesting devices. I could understand why there is a FortiGate inside because it is possible for the providers to work on the device when they're not at the office. So they would need some sort of VPN to connect into the management aspect. But the most important part is they somehow have a DVR device inside that network. So a DVR device is a box that you can connect multiple cameras to and turn those cameras into internet cameras. And I took another look at that device, and it appears that it is also full of command injections, and you do not need any fancy pony methods. So that allows me to pull off an interesting attack flow. So I experimented a bit with all the bugs I have on hand, and I'm able to pull off an attack chain. So if I start from the internet side, and interact with that DVR device inside the management address block in that provider, I can somehow become management. And by using the account enumeration bug I found, I can turn the post-authentication RCE on that device to pre-authentication and perform remote code execution on the devices. So this is a case that actually happened a while ago, and there was roughly 4 million devices affected. And I happen to be a friend with that affected country's cybersecurity director. So that was a typhoon night. I took a call to call that director, and they have immediately removed the entry point, which is the DVR I use in this picture. And all the bugs were fixed in around 2 weeks. So this attack path no longer works right now. So let's move on. For the past 10 to 15 minutes, I have presented 2 cases. We have a case where we are able to perform remote code execution on roughly 4 million devices. And those bugs were fixed immediately, and thanks to our friend's help, it was fixed in around 2 weeks. For the case 1, I'm able to bypass the vendor's implementation of TrustZone, and I'm able to extract the cryptography materials from the device. So in real-world scenarios, it will allow me to break the vendor's security compliance for their fixed network, which means I can basically do what I call is to bring my own GPON device. So for that provider, it is possible for you to perform some kind of homebrew or to perform a jailbreak, and to not use that residential gateway they have provided to you. So if you are still following, there's a bug I mentioned earlier about command injections and the ICMP. I took a bit of study, although I'm not allowed to show the actual source file here. But if you take a look on GitHub, you will find out that you can somehow find proprietary information on GitHub. So this actually leads to a certain SDK by a very popular SOC vendor. So what about the ICMP bug? This is actually a bug which I called unstealthy stealth mode. In the documentation of this function, it actually says if you enable this function, you will enable stealth mode, and it shall not allow any device over the internet to discover existence of the target. So keen audiences here may already spot the mistake that is already been made here. I will go to delve deeper. So inside the SDK, when it is all compiled, there's a component called LifeCNS core is responsible for parsing the configuration files and creating all of the other stuff on runtime. So for example, if you have configured the device for stealth mode, then on every reboot, you'll try to parse that configuration file and create the corresponding IP table rules. But for ICMP, if you look into the request for comments number 792, which refers to the ICMP protocol, it actually defines many message types. And echo is not the only type that will warrant a response from the target. Since the device is only blocking type 8, you can also use type 13 and type 5 to provoke a response from the target, thus breaking the guarantees provided by the stealth mode. So you can uncover such devices if you will send it type 13 and try to detect if the device blocks type 8. So to my memory, at best, I think the last time someone have find such bugs is maybe 10 or 20 years ago. And another problem with the command injection I have found in case 2, it actually leads to a bug that exists in the SDK. So inside the SDK, there's actually a documentation about this function, and it says this function is actually intended to be used only in the command line interface, but it is possible for the OEM to link this function against other aspects on the device. And this behavior will lead to command injections everywhere. So I have reported these 2 cases to the vendor. It is actually a very interesting reporting process because in the beginning, I have reached out to the vendor saying, hello, I have found some bugs, but I have found them by looking into a source code leak. Are you willing to accept this report? And they said yes. So after I have sent the reports to them, they have fixed it very quickly in around 22 days, which is very impressive in the industry. So let's give a quick summary before we go to the mitigation part of this presentation. So for the past hour, I have presented some cases. The case 1 is the TrustZone bypass leading to key extraction. Case 2 is how to perform a research from the board, starting from there, and to perform code execution on the ISP's remote management aspect, and to take control of the ISP's residential gateways. And also, I have demonstrated some methods to find bugs in the SDK that could be shared by many devices. So let's move on to the mitigation part of this presentation. I think the prime question here for the audiences right now is everyone will try to ask, how do you detect the compromise of residential gateways? The problem with this is because the adversaries could update the gateways with rootkits or undetectable backdoors, and it can always reply you that the gateway is running on the correct version of the firmware. And according to the research I have done against so many devices, it appears that a lack of TrustZone/secure boot is very common among these devices. So for the devices, oh, hello. Yeah. So for the devices, there is no way to validate if it is running on the real firmware that you intend the device to run in the first place. I propose a method. I call this integrity check canary. So if you have a remote management aspect and if you have a residential gateway, you will try to push a new firmware and embed a secret in the firmware So this is basically a cat and mouse game, but you will usually be faster than the adversaries unless they're very keen on getting over you. So you will embed a secret in the firmware, and you will ask the Residential Gateway on that secret, and it shall give you the correct answer. But in other cases, you can try this method multiple times and push new secrets every time, and try to ask the secret again. So if the gateway was somehow taken over among us, yes, and it returns you with the incorrect answer, then you will know that gateway is somehow compromised. And how about the end users? There's actually not much one can do as an end user, but there are several methods that allows you to control the damage. For the end users, there's something that you can do. For example, you can try to employ another gateway behind the residential gateway. So essentially use two gateways, but configure the second gateway to block any request that comes from the private address range. It may not help you in every case, but in some cases it may help. Another way you can do this is try to configure your residential gateway as a modem mode. So I believe this mode is pretty common here in the UK. So try to figure out if you're able to disable the layer 7 aspect on your residential gateway and only use it to perform modulation and demodulation between the media medium. So how about the providers and the OEMs? I think one recommendation is pretty imperative for them to implement, which is try to detect abnormal network behavior in their control plane. So let's go back to our case 2 attack flow. If you somehow have a mobile device or a vulnerable management expert in your management network, and if someone wants to launch an attack from the internet side to your management expert, in some cases, the attackers may want to install extra artifacts from other places, or to launch attacks against your gateway. You can try to detect these two behaviors because this is something that will not happen every day. And how about the others? I think the other recommendations from me is try to mandate a set of baseline and standards. And before that, try to mandate the use of hardware-backed secure boot and try to mandate the proper use of TrustZone. And there are several security standards that one can refer to. I don't think they are applicable to residential gateway as is, but you may be able to get the spirit from these standards. And they shall definitely apply secure coding practices. Otherwise, they were writing their softwares like 20 years ago. So how about the upstream vendors, the sock makers? I think a lesson that I have learned in this research is the OEMs may utilize the SDK on their own volition, which means even if you write a very huge, please do not use this function outside somewhere. They will still use it, and they will use it to blow off their entire leg. So for the upstream vendors, it is imperative for them to employ secure coding practices and to employ defensive programming, which is you have to actually try to prevent your downstream OEMs from doing the incorrect stuff. They shall employ the socks with secure boot or TrustZone, which they are already doing right now. However, one thing they can do from that is they have to demonstrate the usage correctly in the SDK and provide very clear and precise instructions in the documentations. So according to the research, it is actually very common for the OEMs to think, we are already encrypting the flash with looks and storing that plaintext key somewhere. Well, this is not proper encryption because the keys were not being held in TrustZone escrow. So it is imperative to mind the OEMs that doing this is not very proper encryption. And I think the SOC vendors have to actually educate the OEMs to how to utilize TrustZone for critical materials that they don't want to lose very easy. So, from this, what do I or we get from this research? I think there are several takeaways that one can learn from this research. One, it appears that most residential gateways and the providers are not very safe. The reason behind that is, according to this research, it appears the gateways are even worse than the IoT devices. And from other data points that I can know, they could be lucrative targets. And they are already shared in numbers because everyone basically has them. Two is one have to actually treat the end devices as hostile. And what does this mean? So when you ship a device to the end users, which is the customers, you cannot control of how, what, or how, or anything will happen to the device. So if you ship any secrets that you certainly do not want to use and do not want the users to be able to read that information out, you have to think very carefully of how to embed this secret inside the device. This can somehow, and the risk can somehow be mitigated by performing a very proper risk assessment and by the usage of modern defensive options, should these options be applied correctly. And on the last one, it appears the software supply chain security is still a very difficult effort. It actually requires effort from every parties, and especially from the SOC vendors, because they actually have to prevent misuse by the OEM. So I think this will conclude my, my presentation. And should you have any questions, you are welcome to send emails or send messages through here. And there are several people I want to give special thanks. One is Ken Kao, my manager at TX1 Networks, and two is Federico Maggi from the Backend Speaker Coaching Program. And I plan to release a white paper and disclosure and write-up very soon, so check out on our blog. And I also have some devices with me. You're welcome to take a look. So thank you.